Decide whether the statement is always or sometimes true, draw a diagram, and explain your reasoning. With this, it's always easier to have like a picture or something to go off of. It says rhombus JKLM. So I'm quickly just going to jot a rhombus up here so I can look at it as I answer the questions. So JKLM. And then for a rhombus, I'm just referencing our family tree right here. All sides are equal, diagonals perpendicular, and diagonals bisect the angles. So all the sides are the same measure. The diagonals here make a 90-degree angle. And then these diagonals bisect the angles. So this is the same measure as this, and this is the same measure as this here, and this here. Okay, and then based on the family tree, something to also note is that a square is also a rhombus. So also going to draw a rhombus like this, J, K, L, M, and then in this square, even to the 90-degree angles, all the sides are the same length, diagonals, and all the 90-degree angles. Okay, so now I have a visual to work with. We can look at the questions. And again, we're answering whether this statement is always or sometimes true. So it says angle L is congruent to angle M. Well, not in this case, but in a square it is. So the answer is sometimes. Okay, and then it says angle K is congruent to M. That is always true because they're parallelograms and opposite angles have to be congruent. So yeah, K would be equal to M always. Wait, why can't I spell? Always. Opposite angles are congruent in any parallelogram. Number 3, JM congruent to KL. JM congruent to KL. Yeah, opposite sides have to be congruent in these shapes. So always opposite sides congruent. Next, JK congruent to KL. In a rhombus, all the sides are equal. So yes, JK would be equal to KL. Always. All sides equal in rhombus. Okay, number 5 is JL congruent to KM. So we're talking about the diagonals now. Is JL congruent to KM? Not in this rhombus, those diagonals aren't congruent, but in the square it is. So sometimes in a square. And then last but not least is JKM equal to LKM. JKM equal to LKM. Yes, because the diagonals bisect the angles. Always diagonals bisect the angles in rhombus. Okay. Next section, it says classify the quadrilateral, explain your reasoning. Some of these are kind of hard to see because they like colored it in. So classify quadrilateral, explain your reasoning. It shows that all these sides are the same measure and all the angles are the same measure as well. So what I'm going to do, I mean, you guys can probably tell it's a square. Looking at my thing, it is a square. So I will write that down. But also, so that would be the most specific classification, but something to also consider, I've seen this on testing as well, they'll have you like select all the shapes it is. Using the family tree, take a second to zoom out. Okay. Focus. Using the family tree, a square is also all of its ancestors. So a square is also a rhombus, a rectangle, and a parallelogram, and a quadrilateral, because it also satisfies the specifics for all those shapes. So we're going to just make a note that a square is also a rhombus, rectangle, parallelogram, and quadrilateral. Again, very common question for them to have you like select all. Then number 8, again, it's kind of hard to see on this, but it shows a 90-degree angle. It shows the opposite sides equal. So this would be a rectangle. And so a rectangle would also be its ancestors, which would be a parallelogram and quadrilateral. Okay, again, rectangle has the 90-degree angles. So also parallelogram and quadrilateral. And then this one here, we can see that it doesn't have the 90-degree angles. It shows consecutive sides are equal. And then remember, in a parallelogram, opposite sides are equal as well. So in this case, all the sides are the same measure. So this is a rhombus. And it's also a parallelogram and a quadrilateral. Okay, last section, it has us looking at angle measures. This specifically says that this is a rhombus, or all these are rhombuses. In a rhombus, remember with angles, the diagonals are perpendicular, so these diagonals are going to make a 90-degree angle, 4 90-degree angles, and then diagonals bisect the angles, so these diagonals are going to break those angles exactly in half. And also remember, because this is a parallelogram, like your opposite angles, because it's a parallelogram, your opposite angles are equal, and then consecutive angles are supplementary, if we need to know that. So that's how we're going to figure this out. Okay, so 11, it's a rhombus, so this right here is 90 degrees. It gives us 27 degrees, and these diagonals bisect that angle, so then 4 would also have to be 27 degrees here. Opposite angles are equal in a parallelogram, so then this would also be 27 degrees and 27 degrees. Okay, and then we need to figure out what 5 and 6 are here. There's different ways to do this, but consecutive angles are supplementary. 27 plus 27 is 54. So we can do 180 minus 54. And we get 126 for like the whole thing. And then divide that by 2 to get each one. 63. 63 and 63. Okay, number 12. Again, it's a rhombus, so this has to be 90 degrees. Diagonals bisect the angle, so 4 would be 48 degrees. Then opposite angles are equal, so this would be 48 degrees. Then for 2 and 3, we could do it the same way we did before. Some of you might be more comfortable working with the triangles. So you have all the triangles here. You could use the angles of the triangles to figure out that missing angle. So if this is 90 degrees, this is 48, you can figure out the missing one that way. So you can do 180 minus 90 minus 48 to figure out angle 2. And that comes out to 42 degrees. So this is 42 degrees. And then since this line bisects that angle, this is also 42. Let's see. Opposite angles are equal, so this is 106 degrees. And then as far as these go, these angles supplementary to this. So I'll start out 180 minus 106 to get 74. So the whole thing's 74 degrees. I got to divide it by 2 among those two angles to get 37. So this is 37, 37. Opposite angles are equal, so 37 and 37. Okay, we're actually not going to do number 14, but there's one that I want to add because it's on the homework. On the homework, there's one with rectangle. So we're just going to add a rectangle here and then fill in the angles. So let's say rectangle. And here, I'll draw it out in color to make it easier to see. Okay, here is our rectangle with the diagonals. Ooh, that's not perfect, but it's okay. That's supposed to go to the corner. Okay. Okay, there is our rectangle. And for a rectangle, all of these are 90 degrees, right? And then this is actually not 45, hold on. All of this is the same measure. And then they give you one measurement and they say this is 37 degrees, and they might ask you about any other angle. So based on this 137 degrees, we can figure everything out though, because remember the diagonals are congruent and they bisect each other, making isosceles triangles. So if this is 37 degrees, then this over here is 37 degrees. And then because these are congruent triangles, like they have the same dimension, this is 37 degrees and this is 37 degrees. You can use a triangle to figure out this angle here, like 180 minus 37 minus 37 equals 106. Opposite angles are equal, or vertical angles are equal, so 106 here. These two form a linear pair, so 180 minus 106 equals 74. So 74 here and 74 here. And then these two, you could use the rules for isosceles triangle to figure it out. Also, you have 90-degree angles, so 90 minus 37 would give you this angle, which is 53 degrees. And then all these would be 53 degrees, 53 degrees, 53 degrees, and 53 degrees. All comes together. Okay, promise, last one, square. I want to make sure that you have an example. Because we talked about the angles of a square, but we didn't write it down. So square, right here, the most perfect of shapes, all the sides are equal, and the diagonals. Diagonals are the same measure. They make 90-degree angles, so 90, 90, 90, and 90. The diagonals bisect the angles because it is a rhombus, and those corners are 90 degrees. So on each side of that diagonal is the 45 degrees that you were talking about, Alex. 45 degrees. 45, 45, 45, 45, 45, and 45. So for a square, they actually don't need to give you any measures to start with. It's always those measures. What's that? With the rectangle? It would... No, that's interesting. Huh. I don't know. If somebody can think of why it would be. Maybe it's always the same? That doesn't make any sense, though. I don't know. I have to think about that. Okay.